All right, so for 6.4, we're going to take a look at radicals again, but specifically these radicals are going to be contained somewhere within a binomial. So maybe like 2 plus radical 7 is a term or a factor that we're going to look at. And how do we multiply and simplify these expressions that are products and quotients? So let's take a look at the first. Our rule, the simplest rule. When you're multiplying two things that are irrational binomials, think of FOIL. Think of FOIL. Why can I remember that? Well, here's the reason. Remember the other day when I had this? I told you could add these together because it's like this, really. Right? That's pretty much what it's like. Well, it's the same thing here. Today we're going to look at something like this. And if I think about this as this instead, I would have to FOIL that out, wouldn't I? So again, we look at the radical as if it's a variable and treat it the same way. So when I have this expression here in red, and then I'm boxing in right here, if I have that expression, I have to remember to FOIL it because I'm really thinking of like this. You can think of it like that if you need to. But remember to FOIL. Part A, what do you get when you FOIL? And you could probably do all these almost on your own today because it's just FOILing at this point. You have to just be careful, right? Don't make any careless mistakes. Remember, FOIL first, outer, inner, last. Okay, double distribute if you want to. Think of it that way. But make sure you FOIL. So 4 times 5 gives me 20 for the first one. Then I go outer, which is going to be this 4 times this negative 3, or negative radical 3. So it's going to be negative 4 radical 3. That's the red. Then in blue, so we're going to do the inner now, right here. We have the radical 3 times 5, which is just 5 radical 3. And then finally last in green here, we'll see this is root 3 times root 3, but it's a negative 1 on the other end, which gives me root 9, which is really just 3. Again, take a look at that last part. You have root 3 times negative root 3, so that's going to give me negative, then the root symbol 9, which is just 3, so negative 3 on the end over here. Okay? And then collect like terms. I've got 20 minus 3 is 17, and then I've got negative 4 radical 3, and a positive 5 radical 3 gives me a 1 radical 3. Again, combine like terms. These are like terms right here. And these are like terms right here. And combine like terms. 20 minus 3, 5 radical 3, minus 4 radical 3 gives me the 1 radical 3. So again, your method here is FOIL and collect. FOIL and collect. Go to part B on your own, please. Part B, don't let it intimidate you because there's a coefficient in front of the radical 2. Treat it like you treat any other number. If you have to multiply a number by that 4, go ahead and multiply it. But remember, stuff that's on the outside can't multiply by what's on the inside. Can't multiply the outside of a radical with what's on the inside of a radical. Ever. Only outsides multiply outsides, and insides multiply insides. I'm going to do it in the order of FOIL, so when you're checking, you know the order I'm going in. Okay, but you could do it in any order for double distributive. So I'm going to start with the radical 2 times the 3, which is just 3 radical 2. That's first. Then outer, I've got radical 2 times 4 radical 2. So that's just going to be plus 4 times radical 4, which is really just going to give me a 2 here. And 4 times 2 is really just going to give me an 8. Take a look at what I did. I kind of tried to show you crossing out. So here, when I do the outer part, I have radical 2 times 4 radical 2, which is 4 radical 4, because the radical 2 is multiplying to give you radical 4, which is really 2, and 4 times 2 is really just 8. And the inner terms are negative 6 times 3, which is negative 18. And then the last terms are going to be negative 6 times 4 radical 2, which is negative 24 radical 2. After that, I'm going to collect like terms. I've got 3 radical 2 minus 24 radical 2.
Which is negative 21.
And then the middle terms, I've got an 8 minus 18, negative 10. Okay, go ahead and check your work. Make sure it's right. This is the order you're going. First, outer gives you this, which reduces to 8. Inner gives you this. And the last two multipliers give you this. Make sense of what's happening. If it didn't click to you at first, the last term, you have a negative 6 times 4 radical 2. Well, the negative 6 at the top up there, and point so you can see, this negative 6 right here multiplies by this 4 to give me the negative 24, and then the radical 2 has to carry down. So that was the last part of FOIL. So whenever you have something on the outside here and you multiply by just an integer, these numbers multiply each other, and the radical 2 just gets carried down. What do I do for part C that makes this, I guess, like a half a step more challenging?
Just have to double make it 2.
Yeah, write it twice.
Yeah.
Okay? 2 root 3 minus 4 root 5. And then what you can do is just get rid of the square. Okay, rewrite it like that if you need to. So that you recognize the fact that you're going to have to FOIL here. Okay, 2 root 3 minus 4 root 5 times 2 root 3 minus 4 root 5. So definitely FOIL this out. I'll rewrite it down here. I'm going to write it all out, and then we'll simplify just in case anybody's been a little bit lost with this. So first I get that. Outer, I get this. Inner, I get this. And last, I get this. Simplifying. Okay, so go through every step if you need to see what you'll be doing with this process. Do the last one on your own, part D, and we'll see if you can get to the answer. Any questions on that? Look at the explanation for part C. If you could do part C here, you clearly know what you're doing with the rules. Outers multiply outers, inners multiply inners. And I mean that as far as with the radical is concerned. Whatever's inside the radical can multiply what's inside the radical. The outsides have to multiply by each other. Oops. What kind of an answer are you going to get for part D? Answer that question. What kind of an answer? Not what answer, but what kind of an answer? Will it be irrational? Will it be rational? Will it be an integer? Will it be a whole number? Will it be negative? Will it be odd? How would you characterize your answer?
A whole number 2.
Yeah.
Just a number.
Say again?
Just a number.
Yeah, it'll be, well, let's say an integer. It'll be an integer. It'll be an integer value, your answer. Why is your answer for part D an integer? No, you know. Look at part D. Look at the setup of the original multiplication you're doing. Why is your answer an integer?
Because it's one is positive and one is negative, so then they cancel out. Like the negative 3, 1 is
What cancels out? Be more specific.
the roots.
When you multiply it out,
Yeah. Oh.
because certain things do cancel. You have to FOIL it out, right? FOIL?
Yeah. When you fill out like the 5 and 5 looks like always perfect.
Good. So it becomes a perfect square.
And then 7 and 7 is perfect as well.
Good.
And then
What about the middle terms? What happens then?
it's minus and plus is it becomes 0.
Yeah, because what is this an example of? What is this an example of?
Difference of squares.
Difference of squares. Remember when you factor x squared minus 4, you get x plus 4, x minus 4. That's what this is written as. Look, this is like x minus 4, x plus 4. Do you see that? You see the parallels in there? Now, the idea of this is called binomial conjugates. I'll talk about in the next slide, but it's called binomial conjugates. And binomial conjugates simply mean that one sign is positive and one sign is negative. Okay, your answer for this was what?
Negative 43.
Negative 43. Okay, negative 43. Again, when you multiply it all out, you get 4 root 25, and then the middle terms cancel. That's 6 root 35, negative 6 root 35. Then you get a 9 root 49, which really just be 45, or no, sorry, 20 minus 63, giving you negative 43. Okay, so let's write down this. Let's write down the term binomial. I thought I wrote it on your slides. I have it in my notes. Binomial conjugate. Oh, plural, I guess. Whenever you have something that can be written in the form x plus some number and x minus some number. Okay, anything written like that, they're called binomial conjugates. We know the term binomial meaning two terms. There's x and there's y, two terms. And conjugates meaning plus or minus. Now, keep that knowledge in the back of your mind. That when you multiply binomials with radicals, you can get a numerical integer or integral answer, integer value, integral answer if they're binomial conjugates. Think about part D, that since they were binomial conjugates, you got an integer answer. Okay, keep that in the back of your mind. Go to the next slide. How can I simplify part A? There's nothing I can do. I can't divide 3 by 2 minus radical 5. If it was the opposite, if it was 2 minus radical 5 over 3, I could divide the 3 into both. But I can't here. But I have a radical in my denominator. I know, it's probably broken, James, that's why. I have a radical in my denominator. And if I want to get rid of that radical so I can rationalize the denominator, right? So what do I do? I want to rationalize the denominator. I need to make the denominator an integer. Think about the last example. What can I do? What can I do for part A? That's what we have. I need to rationalize the denominator. Yesterday, the day before, we said, okay, multiply by root 5 over root 5. And you can try that here. It won't work though, because the root 5 here will multiply by root 5 and make 25. Then you have 2 root 5. If you put a root 5, it has to distribute. So that doesn't work. We can't multiply by root 5 over root 5. Alex?
Multiply the bottom part, 2 plus the square root of 5.
So if we do that, what do we also have to do?
Put it on the top.
Very good, Alex. Well done. Okay, so Alex recognized that the only way you're going to be able to rationalize the denominator is by coming up with a term that ends up being an integer, or a rational number, in this case an integer. So to do so, he uses binomial conjugates. And remember the denominator, do that if you need to. Please remember, you have to FOIL. This is not 2 minus, and then multiplying over 5 by both. This is a FOIL problem. The top you need to distribute. Inner and out, the middle terms are always going to cancel. Always, 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 always. When you use binomial conjugates. So don't even write them out, please. Please don't write them out. So all the bottom you have is 4 minus radical 25, which is really 4 minus 5, which is negative 1. And the negative 1 can go into both of these, make it negative 6 minus 3 root 5. Negative 6 minus 3 root 5. How is part B going to differ from part A? How is part B going to differ from part A?
You just go to the top.
Yeah, it's the same as the other part, except the top has to be foiled also. So for part B, go ahead and practice. Oops. If you need to remind yourself to foil, put parentheses if you have to, but remember to foil. The numerator you can't really do too much with. You can combine the middle terms, obviously. But besides that, oh no, you can, I'm sorry. Obviously, they're different numbers, 3 and 5. So you really can't do anything with the numerator. The 15 you can break up into 5 and 3, but then you have root 5 times root 3, and where do you really put those? It's not worth grouping them with the others. So unfortunately, the numerator is going to be a long numerator here. We just leave it alone. So it's the same answer you have, except here you're just going to have 33. Okay, again, look at the numerator. There's no like terms. Even the radical 15, because you can break it into radical 5 and radical 3, it doesn't really allow you to combine with these unless you group them together, which won't make it any simpler than it is. So that's all you can do for part B. Part C is no different than what we've been doing, except we have all radicals now. Okay, but recognize that the radicals are individually placed. They're not over the entire numerator or the entire denominator. Same deal. Foil through. Combine like terms. Again, though, the denominator should become an integer value because you still have perfect squares that result. Now, what can I do here? Or what should I do here at this point? A lot of you are probably beyond this already, though. What could I do with the 12? What is 12? Root 12, really? Yeah, break it into 4 and 3. Make that root 4 times root 3, which is just 2 root 3. Again, that just simplifies that. It doesn't do much for us beyond. The 21 is still 21. They can't break that into anything that's a perfect square. Can we break 42 into anything that's a perfect square? Does 4 go into 42? No. Does 9? No. 16? Goes into 48, right? 16, 3, 48. So nothing we can break the 42 into. And then 3 minus 6 is negative 3. No cancellation that's allowed here. If these could be broken into further perfect squares, and hypothetically you could take it out of 3 here, you could have canceled these 3's, but this 3 still goes into all of these. So this would have to be root 6 over negative 3. This would be 2 root 3 over 3, because these negatives would cancel. This would be root 21 over negative 3. And then if there were a 3 out front here, those 3's would cancel and just remain as negative or minus whatever was left on the right. Okay, so reduce whenever possible. So this whole concept of this lesson is just the idea of binomial conjugates. Okay, binomial conjugates, that was the whole reason we did this. It's a very useful technique. You're going to use it in calculus and pre-calculus both, when you have to either derive different functions, or sometimes you have to do different proofs to show things that are true. So you're going to have to use the technique to get your analysis to come out properly. You also see it a lot if you guys end up going on to take honors physics, which most of you will, when you're juniors, and in AP physics, you'll see a lot with binomial conjugates and difference of squares. Okay, but this is how they're related to radicals here. Questions? A lot of it is just practicing, right? It should be pretty straightforward. It should be pretty easy, this section. Keep in mind your test coming up. Let's just speak about it for a second, because it's a lot of material, but it's a lot of rules and practice material that you have to work on. So I would recommend definitely getting a head start on that problem set. I would not wait. Okay, what does it do for you guys? Monday, right? Problem set? So maybe tonight, look at like a section or two at least. So before you go into the weekend, you have a little bit of leeway going into, instead of doing, because you have 5-1, 5-2, 5-4, 6-1, 6-2, 6-3, 6-4, and 6-5. Okay, so it's 8 sections out of your text. So it's a good amount of problems, so make sure to get a head start. I saw some of you for office hours yesterday. If you struggled with the quiz, if you think you struggled with it, I'll grade them for sure today. So you can come by if you want to get it after school. But if you want to go over something that you're confused with, please come by, let me know. Okay? I have a doc's appointment today. You can hear my voice. I've been sick for about 3 or 4 days now. So I'm going to hopefully don't have like anything like, sinus infection. But I'm going to go there around 3:30. So if you can come by like right after school for half an hour, I'll be here. And then I'm going to shoot out to go over there. So if you have a question about anything, if you're struggling with the quiz, with the homework, I have not given you a 3rd quarter project yet. I'm going to. I just honestly haven't finalized what I want it to be. Okay? So it's tough to find a project that's related to this, because this is all like just skill work. This is not word problems. Notice there's no word problems in this section, so you're not going to have any word problems in your test. So this test is going to be a lot of multiple choice, and then those short answer, like where you can, work through the steps, but not word problems at the end. Okay? All right, good. We have a little bit of time to start. You're welcome. You got a head start on the homework if you want. Take a look at it. Feel free to. You got a head start.
Ends at 10:58. It's exam.
Obviously, if you have any questions about your grades, the quarter, stuff like that, you know what they are, you get the report card, you're always welcome to ask.